Good morning. Good morning. How are you? How are you doing, my best learners? I wish that everything is okay with you. Okay, today we are focus on a new method. Okay, we'll focus on the discriminant formula of Mourad Sultan Ezouidi, and through this discriminant formula, we'll give you the exact roots. Okay, the exact values that satisfy your fourth degree polynomial equation. Okay. So let's start learns. I'm going to share my screen so that you can work with me at the same time. Okay. And of course, it's an advice to prepare, let's say, some papers, okay, A4 papers in pens, okay, an eraser if it is possible, or rubber or something like that, okay, so that you can start with your pioneering methods, okay, your Tunisian researcher in the fields of mathematics. Okay, now learners, I'm going to start. We told that I will solve problem to the power 4, okay, using my own discriminant formula, okay, that will give you exact roots, okay, meaning that we'll never work with the approximation method, okay, um, or with the error estimation. Okay, so learners, I will just start. I'm going to share my screen, learners. Okay, okay, now you are ready. Okay, so we start, learners. I will just put this somewhere here. Okay. Now I'm going to start, learners. We have polynomial to the power 4, and we are going to evaluate first s minus 1, then s0, then s1, then s2, and we stop at s3 because it's polynomial to the power 4. Okay, let's start, learners. I wish that this example will help you okay, understand decimal formula of me. Okay, so this is polynomial to the power 4. Okay, I just yes, this is polynomial to the power 4. I'm going to solve this, learners, this polynomial raised to the power 4. It's called fourth degree polynomial equation. Okay, I'll put this here. Okay, so this is our polynomial to the power 4. You can see this is a polynomial to the power 4. Our target is to find, let's say, the coefficient of the new polynomial to the power 4, of course, that is related to the original polynomial. Okay, we can say that this polynomial is has a form of PQ, okay, where 4, let's say, denotes learners its degree, and Q denotes its order, and not its order of multiplicity. Therefore, learners, I'm going to see that R is belonging to the set of numbers minus 1, 0, 1 in order to find the values of SRPQ dash. Okay, this SRPQ dash will give you the new polynomial to the power 4. And regarding to this, that you are going to work them out, you will find the x roots of this new polynomial. Okay, then you will pose that alpha, let's say, subscript k belongs to 0 and 4 is equal to L0 of all the q plus the x roots, or divided by 4 because the highest power here is 4. Okay, now learners, we just start. So it's clear when putting, let's say, k equals 0 in the discriminant formula of me, you will get by convention that s minus 1 of order s minus 1 of order, let's say, r is equal to 1. Okay, therefore I will just, this is the coefficient, I can erase this, no need for l minus 1 because it's clear by convention is equal to 1. Okay, just need the first coefficient, the first 4 coefficient of my original polynomial. Okay, I'll just make like that. Okay, I will wait for this. Okay, so these are called coefficient of my original polynomial learners. Okay, I will use them to find out the values of S0 and S1 and then S2 and S3. Okay, so this one, the discriminant formula of your mathematics teacher, Mourad Sultan Ezouidi, and this formula had been generalized for any polynomial to the power and just putting k equal 0, 1, up to n minus 1. Okay, so this is my own formula, discriminant formula of me. It's written as s minus 1 of O with the sum from 0 to k combination n minus r, choose k minus r, n raised to the power r, between parentheses, negative L0 for the q raised to the power k minus r times L r minus 1 of OG. Now learners, I will start. Just I will develop, let's say, the value of s minus 1 when r equals 0. And of course, I'm going to expand, let's say, the value of s0 when k equal 1 and so on. Okay, let's focus on this. So for k learners, to put k equals 0, we get the value of s minus 1. By convention, we told this one learners is equal to exactly equal to 1. Okay, because here learners, you can see that the sum from 0 to 0 combination n minus r, choose r, n raised to the power r, between parentheses, negative L0 of all the q raised to the power negative r, L minus 1, Lr minus 1 of all the q, in fact, is labeled as, is known under the name of, or under the symbol s minus 1 of r equal 1. Okay, now I'm looking for finding the value of S0. We told before that the value of S0 of order R is always equal to 0, because we calculated and we uh, develop, let's say, the discrete formula. When k equal 1, we obtain a 0 of as 0 of order r is equal to 0. Okay, so this is the formula. I'll just replace k with 1. Okay, and we'll check. So we told a 0 of order r is the sum from 0 to 1, combination n minus r, choose 1 minus r, and raised to the power r, between parentheses, negative L0 of order q raised to the power 1 minus r times learners Lr minus 1 of order q. This one, when r equals 0 and r equal 1, you'll obtain this one combination and choose 1. In fact, it's n raised to the power 0 is 1 times negative L0 for the q raised to the power 1 times L minus 1 for the q, plus when now r equal 1 learns, we will get combination n minus 1 choose 0, n raised to the power 1 times negative L0 for the q raised to the power 0 times what? Times L0 for the q. Okay, so after simplifying and putting L0 for the q as a common factor, you will just uh, uh, simplify the value of S0 for the R in terms of negative combination n, choose 1 times L0 for the Q times L minus 1 for the Q plus n L0 for the Q. This one learns, you can see this one, L0 for the Q here and here are called, it's called common factor. So put it outside the brackets, you will get n minus combination n choose 1 is 0. Therefore, it's clear for you learners that the value of S0 for any polynomial to the power n, okay, is always equal to 0, because the sum of the x roots here is equal to 0. That's why S0 for the q is 0. Okay, now I'm going to calculate if it is possible. Okay, therefore this is S0 for the r is equal to, we told negative 4 times 68 multiply by 1 plus 4 times 68. It's clear that is negative 272 plus 272 equal what, learners? Equal 0. Therefore, I'll just write like that. Negative 4 times 68 plus times 1, okay, times 1 plus 4 times 68, learners, is equal to 0. Therefore, a 0 of order R is always equal to 0. Okay? For any polynomial that you are going to work, okay, the value of a 0 of order R is 0. Okay? Of course, we are going to use this formula. Now I'm attending learners to find the value of S1. To find the value of S1, learners, you just suppose, or you just put k equals 0 in the discriminant formula of me. Okay, this is the discriminant formula when k equal 2. I'll just start working on it. Okay, let's see, learners. Okay, so we told that, okay, this one. We told that S1, learners, is the sum from 0 to 2, combination n minus r, choose 2 minus r, n raised to the power r, between parentheses, negative 0 for the q raised to the power 2 minus r multiplied by lr minus 1 for the q. I will go immediately to the last expression after developing and simplifying uh, S1 in its lowest term. We can see that the value or the expression of S1, learners, is equal to minus combination and choose 2, okay, times L0 for the cube plus n square, uh, n square times L1 for the cube. This formula S1 is always true for any polynomial to the power n, okay? Of course, this S1 for the R um, has a relationship between the coefficient, the first two coefficient, okay, with the exterm, with the uh, with the with the exterm of exterm, yes, that had been raised to the power n minus 1 and n minus 2. Okay, so it will be negative combination n choose 2 times L0 for the q squared plus n squared times L1. We are going to just to focus on the last expression, okay, and replace n with 4, okay, in this formula. You will get the value of S1, okay. Now, learners, I will just suppose I will, okay, I will make this one. Now I will continue, learners, doing what? I will continue calculating the value of S1. Okay, okay, it's very important, this one. So this is the value of S1 that I'm going to work it out. Okay, let's do it together. We have, okay, I put it up. Okay, like that, Mr. Murad. We told that negative combination and choose 2 means negative combination for choose 2. Okay, for choose 2 to be negative 6 terms times what? Times the value of L0 for the Q raised to the power 2. This is L0 for the Q times 68 squared. Okay, plus, learners, what? Plus n squared is 4. 4 squared is 16 plus 16 times what? Times the value of L1 of ODQ. The value of L1 of ODQ is 101 times, learners, 101. This has to be equal to negative 26,128. Therefore, we calculate the value of S1. Learners, here, uh, it's clear that we found the value of S1 and S0 and S minus 1. As you have a polynomial to the power 4, you should, okay, or you have to find the values of S2 and S3, okay? So let's start like that. Now it's clear that S1 is equal to negative 226,128. Okay, Now learners try to find out the value of S S2, of course. Okay, it's clear. Go to my own discriminant formula and replace k with 3 in the formula. You just, after developing and writing your expression of S2 in lowest term, you will get that is k that is equal to the last formula is that okay. The last formula I will give a color it with different color. Okay, that is very important. Every student, every professor, every teacher has to memorize the last one, which is this, learners. I will give okay this one very important. Okay, so as two learners is equal to 2 times combination n choose 3 L0 of all the q raised to the power 3 minus combination n minus which is 1 n squared L0 of all the q raised to the power 1 times L1 of all the q plus n cubed times L2 of all the q. This one is very important. This formula of S2 had been derived from the discriminant formula of Mourad Sultan Ezouidi when k equal 3. If you just substitute k with 3, it will be S3 minus 1 will give you S2 of order R equal the sum from 0 to 3, combination n minus R, choose 3 minus R, n raised to the power R between parentheses negative 0 for q raised to the power 3 minus R times L R minus 1 of q. This one, when R equals 0, and 1, and 2, and 3, you will get this one means you will get combination n choose 3 times minus L0 for the q raised to the power 3 times L minus 1 for the q. This one is always 1 plus n combination n minus 1 choose 2. Okay, times between parentheses negative L0 for the q raised to the power 2 times L0 for the q. You can note this one, it's a common factor. With that, you can put outside the parentheses. That's why here it's written L0 for the q raised to the power 3 between parentheses negative combination n choose 3 plus n combination n minus 1 choose 2. Okay, the rest had been written as they are, no change. Okay, so as a conclusion, the value of S2 that is written in terms of combination and the coefficient of the first three terms means L0 for the Q and L1 and L2. Okay, this is the most important formula for um, for the most important formula for for S2. Okay, therefore you have the formula. Just now substitution. You will try to figure out the value of what the value of S2. I will give you time to use your calculator, learners, till I prepare what I'm going to demonstrate or to show. So we'll use the first three coefficients of my original polynomial to calculate the value of S2. Okay, learners, don't forget that this formula S2 had been generalized for any polynomial to the power n, means any polynomial to the power n to be solved, you should calculate it as k minus 1 of order r. Okay, of course, according to me, according to my own method, this will help you to find your new polynomial that had been related to the original polynomial that you are going to work with or to work out its exact roots. Okay, let's now work, learners. I will just calculate the value of S2 if it is possible. Mhm. We told that S2 equal S2 is equal to what? Use a calculator. I will give you time to work it out. Is like that, learners. So I will just write 2 times 4. Why times 4? Because combination 2 choose 1 times combination 4 choose 3 because n is 4. N is the highest power of the polynomial equation that I'm going to solve. Therefore, I will just write 2 times 4 is 8. I will just write 8 times, learners, 68 square to the power 3 because L0 for the q to the power 3. L0 is 68 times as raised to the power. Where is my mouse? Yes, here my mouse. Raised to the power 3. Correct. Then you can see that minus combination n minus 2 choose 1, or n is 4. That's why 2 choose 1 is 2 here. Certain 2 times l squared is 4 squared times l0 is 68 times l1 is 101. So I will write minus 32 learners times 68 times what? Times 101. Okay, plus n raised to the power 3 is 4 cubed times L2, but L2 is negative. That's why I prefer to write a negative sign in front of my product, means minus what, learners? Minus 4 cubed is 64 times what? Times 35,870. Okay, this one, learners, has to be equal to what? To 0. The value of S2 is equal to 0, learners. Okay, now I'm going to focus on K equal 4 to get the last coefficient of my new polynomial equation. I'll just proceed. Okay, I will just proceed, learners. I will put k equals 0. Okay, I will put k equals 0 in my equation. Okay, then I will focus on the last one. Okay, I will give another color. Okay, therefore, learners, when k equals 3, okay, you will use the discriminant formula. It will be S4 minus 1 will give you S3. The sum from 0 to 4, combination n minus r, choose 4 minus r, n raised to the power r between parentheses negative L0 for the q raised to the power 4 minus r times Lr minus 1 of O dq. This one, when expanding this or simplifying this as or write it in its lowest term, okay, you will get S3 is equal to negative combination 3 choose 1 times combination n choose 4 times L0 for the q to the power 4 plus combination n minus 2 choose 2 and squared L0 for the q squared times L1 of O the q minus combination n minus 3 choose 1 n cubed learners times L0 for the q times L2 of 4 dq plus n raised to the power 4 times L3. You see this one is the last. Okay, it's very important for any polynomial to the power 4, S3 has to be equal always like that. Okay, of course this one had been derived from my own discriminant formula. Okay, just putting k equal 4 to get this one. Okay, now n learners, you are working or you are solving polynomial to the power 4, means n is 4 choose 4 is 1. Okay, therefore I will use my calculator. Okay, where is my calculator, Mr. Murad? I will just write like that. Negative combination 3 choose 1 means negative 3. This one combination 4 choose 4 is 1. No need to write it. Just multiply by L0 for q raised to the power 4 plus 4 squared, because n squared, n is 4, 4 squared. Combination n minus 2 is 4 minus 2. 4 minus 2 is 2. Choose 2, so no need to write is 1. Okay, the value of these combinations are equal to 1 always, okay, because 4 minus 3 is 1. So I'll just focus on this one, learners. I will write negative 3 times what, learners? Times 68 raised to the power, Mr. Murad. We told negative 3 times 68 raised to the power 4. Okay, because again to the power 4 plus 4 squared is 16 plus 16 times, learners, the square of 68, the square of 68 times L1. L1 is 101. Okay, 101 or 170? 101, yes. 101 times Mr. Murad times 101. Okay. Minus 4 cubed minus 64. Okay. Times 68 times 68 times between parentheses negative 35. Okay. 870 close the parentheses because it's negative. What is negative sign? Sorry. I told negative sign. Mm, okay, multiply by 0. I will repeat this. Multiply by 0. Okay. Means this value, when you multiply by 0, it means that you add nothing. I will just make minus 4. Minus is positive plus 64 times learners 68 times 35 870. Good man. Okay, plus 4 raised to the power 4 minus mhm, plus 256 times what? Times 278,000, 278,000, 256 point what? Point 25. This one has to be equal 170,000,000, 170,000,000, 686,000, 680 and 68,000 and 96. So the value of S3 is that. Okay. Now, this is of course is I will uh, correct the value of S1. S1 is 100 and 1 not 1000. Okay. I will close this one. Now, learners, I got my new polynomial. We can see that. In other words, learners, okay, I will just write this with different color. In other words, learners, we told that all the former S0R and S2R are all equal to 0. All equal to 0. Okay, except what? Except learners S minus 1 of order R and S1 of order R and S3. Okay, so after calculation, we can write S minus 1 is 1 and S1 is negative 26,128 and S3 of order R is equal 1,170 million 668,096. Therefore, this is my new polynomial that I worked with. Okay, that I worked with learners. Okay, let's see it. Now, as I calculated learners the value of sk minus 1 of order r when k belongs to the set of numbers from 0 to yes 4 minus 1 to 3, I got my new polynomial. I can write it p of x equal x raised to the power 4 minus s0 of order r x raised to the power 3 plus s1 of order r x raised to the power 2 minus s2 of order r x plus s3 equals 0. Okay, therefore, learners here, I will just erase this plus. I will just substitute S0, no need to write because 0. I will just focus on S1, x squared, and S3, okay, x raised to the power 0. And this one is 0. Therefore, I will just write x for p of x equal x raised to the power 4 minus 26,100 and 28 x squared plus 170 million 668,096 equals 0. Therefore, I can use my own discriminant formula. I would just write, you see this one, the value of S1 that we calculated before for any polynomial to the power n S1 of order h equal negative combination n choose 2, okay, S1 of order r squared plus n squared times S3 of order q. Here, you can see this one, it's a polynomial to the power 4, but I can reduce its highest power. Means I'm going to suppose that x squared equal u, it will be u squared minus or plus s1 of u plus s3 equals 0. Therefore, I will use my own calculator. I will just like make like that, learners. This is my own calculator. I will just, we told n squared is 2, 2 squared is 4, okay, multiply by 170 million, okay, 668,096, multiply by 4. I will make multiply this by 4, okay, minus what? Minus 26, 128 squared, minus 26,128 squared, okay, squared, Mr. Murad. This one is equal to, okay, equal to 0, means that if s one of order I equals 0, means you will get a double root, okay? Therefore, uh, x squared, because you have 2x squared equal, uh, we told equal what? Equal minus s1 of order r. The formula is minus s1 of order r, okay, plus the root of s1 of order r dash. So minus s1 is minus minus will give you positive 26,128 plus negative root of s1 of order r, which is 0. So this one has to be equal to 26,128 divided by 2 gives 13,064. So this is x squared, learners. Okay, therefore x subscript k belongs to 0, 1 is the root of 13,064 exponential ik pi. Why? Because I can write this as 13,064 times exponential to ki pi. Okay, therefore, now the roots of my polynomial, learners, is as I found, let's say, the value of x k, okay, of my new, this you see xk 01 is equal to that is the roots of this, the new polynomial. To get the roots of the original polynomial, you should write alpha. This is the root, the exact root is alpha subscript k belongs to 01 equal L0 for the q. L0 is 68 plus root of, or plus xk, okay, as you like, plus xk, okay, divided by 4, because the highest power is 4. Therefore, we have the first root is, I can simplify this more, learners. It will be 68 plus 13,064, of course, raised to the power half, times a exponential a I k pi, if divided by 4. You can see that I will appear that is 4 as a common factor. 68 divided by 4 will give you 17. And let's say 13,064 divided by 16. I will just write it here. 13,000 and 13,064 divided by 16 will give you, learns exactly, yes, will give you 816.5. Therefore, this is, of course, inside the root there is 16. Okay, root of 16 will give you 4. So I will simplify 4 by 4, and 68 divided by 4 gives you 8. So the last, here we have double root. When k equal 0, you will get 17 plus root of 816.5. When k equal 1, you will get 17 minus root of 816.5. So we have here, learners, 4 real roots. We don't have imaginary roots or complex number. Now I'm going to go to, okay, go to the, to GeoGebra. Okay, I will just go here. So these are the roots we told. Okay, I can explore this more. I can make like that. The roots are, okay, copy. Okay. The roots are, I'll make like that. When k equals 0, we'll give, this is double root, and the next We have double root here. Okay, go down, it's better. Okay, this is minus. So we have double root. Okay, means 17 plus root of 816.5 and 17 minus, okay, minus what, Mr. Murat? Okay, minus root of 816.5. Okay, now we'll close this one. I will go back. I will go back like that. I need just the first coefficient, the first four coefficient, this one, okay? So I'll just write this. We told, okay. Mm-hmm. I will come as here, learners. Okay. I will go here. If you want. Okay, 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 okay. Okay, Mr. Murad. Okay, good man. J Jabra. Okay. We told x raised to the power 4 minus minus 68 x3 cubed. Okay. Then plus learners 101 x squared. Okay. Then what else? Minus plus, sorry, plus 35,870x. Then learners, okay, minus or plus the last term, I would see. Yes, plus, okay, plus 278, plus 200, plus, plus, plus 278 256.25 equal 0. I'll make copy and call. Okay, so this one, okay, I don't know, Papa. I have a listen, please. After. Okay, okay, now I will tell him solve. Okay, of course, equal what? Equal 0. Why doesn't equal 0? So, okay, now GeoGebra is thinking of the roots. Shit, shit. Okay. Okay. Shit. Okay. He can do it, no problem. I will tell him solve. You see, this is difficult for uh, for GeoGebra, but Mr. Mourad Sultan found the roots. Okay. Shit. Okay. No problem. I will go now to Mathways. Mathways. Okay. It's a site web. Mathways. You see what Mathways can see, learners. Okay. Okay, Mathways, come on, Mathways. Algebra, calculate. Okay, come. Look, when Mathways can solve these kind of questions, he told, if you have other questions, I can help. Okay, let's see GeoGebra خلاص can do this example because he needs to update my own formula, means he needs to write my discriminant formula into logarithm, then he has to plug into GeoGebra application. You see, pathways. Okay, he knows that I'm going to work. He told me that this site can be reached, but I will try to do it again. Okay, iwmathai.com, i.com. Hey, come to your pioneers in methods. Okay, this why this come because of the AI, artificial intelligence. Okay, has a big good touch with this website. Sorry. Okay, I can. Okay. I will enter my problem. I will enter my problem. Okay. Help you. Okay. Look, this is what can you help. Okay. Of course. Okay. He uses what graphs. He make it graphs, not the answer you are looking for, of course. Not this answer. I told you should solve this. Okay. You see, nothing. He did nothing. Okay. Okay. So this is the equation. It's clear. I told him solve. Okay. Okay. Where is it? Where is it? Upgrade. Okay. You see, this is okay. Okay. I will do it again. So this one, the graph. I'm not looking for the graph. Okay. The graph real number has two cuts the x-axis four into 4 points, four roots. Okay. So now Mathways block it. He can't. It can't. Let's say solve this question. Okay. How can I help you? Okay. Again, I will tell you what to do exactly. Okay. Okay. I will tell you solve. Solve. Okay. Solve for x. I am still. Okay. Now. Okay. No, not this. Okay. The chosen topic is not mean for use with this type of problems. Okay. I told solve for x. Solve for x. I will give you now, comma, okay, Control V. Okay, you see, I'm unable to solve this problem. Mathway told that I am unable to solve this problem. Who has the energy to struggle with physics equation? You can solve complex problems with units. Okay, so he doesn't have the answer. You see, I will see now, learners. Okay, ChatGPT. Of course, this one. Okay, you see, GeoGebra can solve this question, and I already explained it. The solution of my polynomial to the power four is that, learners. Okay, is that now if GeoGebra or Mathway use artificial intelligence, it can immediately my answers and put them in the okay, but they need method. Okay, now learners, I will save this one. Thank you for listening. But I'm going to go to ChatGPT. I will tell him, please solve this. Okay? Yes, خلاص. Now I will go, learners. Please try to focus with your math teacher, Mourad Sultan Ezouidi. Okay? ChatGPT. GPT. Okay? GPT memorize everything. Okay? Look, it will tell me go to factorize, go to use. Okay? Newton steps, Newton method, approximation method, but all of them they will give you errors, roots with error estimation, meaning they will give you a root that is near, okay, in the interval, okay, but never be the solution, okay. So ChatGPT, yeah, come ChatGPT, okay, leave this one, and I'll go to ChatGPT, okay. I am Mr. ChatGPT, okay. ChatGPT. Okay, okay. Please solve. Please solve. Solve for x. For x. Okay. Come on. Look. Okay. Okay. Put this here. Sorry. Sure. I can help. Okay. This is my own polynomial. Solve this one. Okay. Solve the polynomial. Okay. You can numerical method or algebraic techniques for finding the root. Since this is a quadratic equation, it might be complex to solve algebraically. Let's use a numerical. I will go just step by step. Let's okay, okay, what is it? We can use numerical methods or algebraic techniques for finding the roots. Since this is a quartic equation, it might be complex to solve algebraically. Let's use a numerical method to find the roots. I will use, you see, Python to find the roots. Let's proceed that. So the roots of is negative 45. Okay, these are the roots approximately, and it doesn't have a root. Look, I will tell him no, your answer is wrong. No, sorry, your answer is wrong. Is wrong. Okay, look, the answer of okay. Okay, let's solve again. Okay, the roots of this polynomial is approximately 45.75. Okay, I will go back now. So you see, okay, now learners, I'm going to close this one and it's streaming.